Okay, so we're solving for trigonometric functions. That's really what we're going to be doing today, is using different operations and different things to solve. Now to solve for x, note the figure below that the equation sine of x equals 1/2 has a solution. So for sine, x equals 1/2 of pi over 6. Yes? What's also the same at 5 pi over 6, as well as 6 plus 2 pi. Because every 5 pi over 6 that we can have adding 2 pi or subtracting 2 pi will be an answer, because it repeats. Because 5 pi over 6 repeats every 2 pi in either direction. Because if we subtract 2 pi, we get over here. So if we subtract 2 pi, we end up here. If we add 2 pi, we end up here. Nope, sorry. If we add 2 pi, we end up over here. I did the other one. So we can add or subtract 2 pi and get these points. Yes? So really, x is equal to pi over 6 plus 2 pi n. Because every 2 pi, we get the same value for sine. And we also have 5 pi over 6 plus 2 pi n for this here. Now, if it just asks for the solution on the interval from 0 to 2 pi, then it changes our answer to just this and this, because those are on the interval from 0 to 2 pi. Yes? Now, if it doesn't include this, then it's this whole thing. Because it's just asking what value is going to make sine 1/2. Well, pi over 6 plus any other coterminal angle of pi over 6. And the same with 5 pi over 6, because we can have multiple. But when it restricts us to be between 0 and 2 pi, well, that's the only values that we can have, then we don't worry about this. It's just this answer here. And you'll see it. Okay, well, let's just solve one. Let's go about solving it, because it's going to be a little bit easier to see when we actually work one out. So sine plus the square root of 2 equals negative sine of x. Well, let's get sine on one side. Let's get everything else on the other. Kind of get like getting x by itself. Well, the first thing we can do is, well, I can add sine of x to both sides, because negative sine of x plus sine of x will cancel out. So I get 2 sine of x is plus the square root of 2 is equal to yep. Because again, we're kind of wanting to get sine by itself. And then what can we do? Still want to get sine by itself, so I would divide both sides by 2. So sine of x is equal to negative square root of 2 over 2. So if we look at this here, we can look at the unit circle and see where is sine equal to negative square root of 2 over 2. So it's in the third and fourth quadrant. So 5 pi over 4. And so this would be our answer if we're on the interval of 0 to 2 pi. Because if we're just on that interval, one time around the circle, this would be our answer. But if they did not restrict it, we would have to add 2 pi in. Because again, this is repeating every 2 pi. These numbers would repeat every 2 pi. So we need 2 pi in. If it doesn't restrict it on the interval of which the values can appear. Questions on this here? Now, yes, we don't have to always have 2 pi in, because if it worked out that, say, it was 0 and pi were the answers, it'd be pi in. Because 0 pi, well, if it's just pi, if I add pi, I get 2 pi. Because it's between those two, and it works out that I could just use pi, because 0 pi is at 0, 1 pi, 2, 3, 4, as it repeats. There's some that we don't have to use 2 pi in if it hits pi, distance apart from those two. And we'll see that when it comes up. And here's kind of the worked out example. Now we can use some quadratics, so 2 sine squared minus sine of x minus 1. And we could use it with secant as well. And we can really, to solve these types, factor the quadratic, or when it's not possible, use the quadratic formula. So we can use the quadratic formula to solve this here. We just treat sine as x. So this would be like x squared and x. So we can still use the quadratic formula. The numbers in front of sine and cosine would be our variables. Or not our variables, but our coefficients. So find all the solutions for 2 sine squared of x minus sine of x is equal to 0. So we can see if we can factor it. So really, what we're looking at, this is almost the same as 2x squared minus x minus 1 equals 0. We can treat it the same way. So if I wanted to factor this, 2x and x. Well, let's do the signs because I skipped over that. Since the 1 is negative, the signs are positive and negative. The factors of 2x squared, well, factors of 2 are only 2 and x is just x and x. Now the factors of 1 are, well, 1 and. So we can check it. 2x times negative 1 would be negative 2x. Net 1 times x would be plus x. We get negative x like we want, yes? Now, if we kept working with this to solve it, well, I would set each one of these here equal to 0, yes, to solve. But we're really not dealing with x. We're dealing with what? Sine, because I replace sine with x. So this here is really 2 sine of x plus 1 is equal to 0. And here I have sine of x minus 1 is equal to 0. So we can solve this one here. So we're just solving it for sine. So we can minus 1 first. We get 2 sine of x is equal to negative 1. And then we can use the unit circle to see where x is equal to negative 1/2, which is going to, again, be the third and fourth quadrant, which will be 4 pi over 3. For negative 1/2. So y? So it'd be the y spot. Yep, 7 pi over 6 and... Yep, thank you. I was looking at the wrong one. And we would add 2 pi in because we're not given a restriction, because it's not given x is on the interval of this. And that there is half of the answer. We just have to solve the other side. So where is x equal to positive 1?
I can't remember if it was straight up or straight down.
Straight up.
Oh, I we put the x before.
So, before 90s are all 1 and 0, and then
Yes.
the two lateral ones.
So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now notice this here, because it is a quadratic-ish equation. We do have a degree. It's a second degree. But this isn't a polynomial. So we can't use our fundamental theorem of algebra that the degree is equal to the number of zeros. Because, well, if we don't restrict it, it's got infinitely many solutions. But if we restrict it, it would have 3 on the interval of 0 to 2 pi. But when we don't restrict it, we have any repetition of these 3 here. Questions on these here? We're good with this here? So we factored it, solved, and we found this here if we're on the interval of 0 to 2 pi. If not, we have others. Questions on this here? Any questions on any of this here so far? Yep. 2. Okay. Now the next one we're going to do is this here, solving these with multiple angles. So 3t is inside here. 2 cosine of 3t minus 1. Well, let's get cosine by itself. Mm-hmm. Yes. So we'd add 1. And then divide by 2. And we get cosine of 1/2. Okay. Where is cosine equal to 1/2? Pi over 3. And? So whenever we plug 3t in for cosine, we get pi over 3 and 5 pi over 3. Yes? So I would set it up like this here. So we just have to now solve for t. Over. Because we flip it and multiply. Calculator will also do it. Here we would get t is equal to pi over 9 because we're dividing both sides by, again. So this here, even though there's multiple angles, we're going to do it the exact same way. We're going to solve it and then solve it again. So we got cosine, so we solve for cosine essentially, set it up, and then solve for the actual value. Because when we plug pi over 9 into 3t, well, the 3 and the 9 would simplify to pi over 3, which would give us our 1/2. Questions on this here? Does this make sense? Yeah. Here. And if we do the 2 pi in, we would have to divide it by 3 also. I'm not going to be as nitpicky on that. Okay? So let's do this one here. Well, to solve this here, well, first we would
Add 2 pi,
add the square root of 2. And then we would divide by 2. And get sine of 4t is equal to the square root of 2 over 2. So to solve from here, we would yes. Yep. That's it. Now, if we had a division, if it was, say, t over 4, then we would multiply by 4. And just get pi. And that's it. Questions on this here. So it's really just solving for sine and then doing it one step further. Because essentially we're taking the inverse of both sides. Because at this step here, we're really doing sine inverse of both sides. And well, these cancel, leaving me with 4t. This gives us our pi over 4. It's essentially what we're doing. But because sine inverse and cosine inverse have bounds, we talked about them being restricted on 0 to 2 pi and negative pi over 2 to pi over 2. It's easier to just physically look at the unit circle and see where does it match up and go from there. Questions on this here? Now really, again, if we had 2 pi in over 4, which would just be plus pi n over 2, because 2 over 4 reduces to 1/2. Yes. That's it. Questions on this here? Using inverse functions. So we look at this here. Secant squared minus 2 tangent equals 4. Well, secant is the same as tangent squared plus 1. Because it's one of our Pythagorean identities. Because one of our Pythagorean identities is our tangent squared plus 1 is equal to secant squared. So tangent squared of x minus 2 tangent of x minus 3 is equal to 0. So we're just using this identity to get to here. Because I need it all in terms of tangent or secant or cosecant or cotangent, sine or cosine. Because I need it in terms of 1. Or at least in a form that I can actually manipulate. So here it was easier to get it into tangent. Since the 3 is negative, the signs are opposite. Well, what times itself is tangent squared? Tangent. And if we multiply this out, it would work out to be, get us back to this here. So here I have tangent of x plus 1 is equal to 0. And here I have tangent of x minus 3 is equal to 0. Well, I can tell you right now, the unit circle is not going to tell us what value of x will make tangent equal to negative 1 or 3. So we have to use our inverses. So tangent inverse of tangent of x is just x is equal to our tangent inverse of negative 1. And we have to do the same thing for 3. Now at this point here, we can plug this into the calculator. We do tangent inverse of negative 1 in the calculator. And if we're not restricted, it's going to be plus pi n, because tangent repeats on the interval of pi. It doesn't repeat 2 pi, it repeats every pi. And that would give us our answer. Now, exactly as we did it here, we replace secant squared with 1 plus tangent squared. Moved the 4 over, factored, and we got this here. X is equal to arctan of 3, and x is equal to arctan of negative 1, so equals negative pi over 4. So you finally get x is equal to arctan 3 plus n pi, or negative pi over 4 plus n pi. And we could have gotten that from same as the decimals. And I'll check decimals and make sure that they are the same. And you can use a calculator to approximate the value of arctan of 3, which we did. And that's it. Questions on this here? Okay.